Right. So chapter 1 assignment, guys. The age of every fourth person entering a department store. Since he didn't mention every single person, it's not a population. So it must be a sample because a sample is a subset of a population. The second one, the age of each employee at the local grocery store. Since we're talking about every single employee at the store, then it is a population. It's a population of employees, not customers, population of employees. Number 3, determine whether the numerical value is a parameter or statistics. Remember, a parameter is a value that describes a population characteristic, and a statistic is a value that describes a sample. A recent survey, once he says survey, guys, it should be a sample because we survey a select number of people. By the alumni of a major indicated that the average salary of 7,500 of its 200,000 graduates was 95,000. So the $95,000 represent the average salary of 7,500, not all of the graduates. So it is a statistic. Number 4, determine whether the numerical value is a parameter or statistics. A survey of 1,208 students was taken from a university of 20,000 students. You see, we only surveyed 1,208 out of 20,000. So the value that came out of it must be a statistic. Identify whether the statement describes inferential or descriptive. He says the average age of students in my statistics class is 22 years. It's just a description of the average. You get the ages of each student, you add them up and divide. You're not making an inference. When you make an inference, you make an intelligent decision based on the sample, then this is inferential. It's just descriptive. Determine whether the data set number 6 is qualitative or quantitative. Well, the number of seats in a movie theater, it's a number that you can add, subtract, so it's a quantitative. 7, the number of the shirts of a girls' soccer team, that's nominal because the number is just a label to identify the person. Okay. Age of a student is a ratio level. Nominal, the data is qualitative, cannot be ranked. Ordinal data is qualitative but can be ranked, put in order, like letter grades. Interval, it's quantitative data, but the 0 means something. And the 2 common examples, guys, are temperature and the year. These are examples of interval. And then everything else must be a ratio almost. Determine whether the study is an observational study or an experiment. A medical researcher obtains a sample of adults suffering from diabetes. She randomly assigns 67 people to a treatment group and 67 to a placebo group. Once you assign the groups, the people into 2 groups, guys, one gets the treatment and one gets nothing, it's an experiment. So this is experiment. Number 10, a report sponsored by the California Citrus Commission stated that cholesterol levels can be lowered by drinking at least 1 glass of citrus product each day. Is there a bias here? Yeah, there is a bias because the report comes from the company that makes the juice. 11, local newspaper ran a survey by asking, do you support the deployment of a weapon that could kill millions of innocent people? Also, it is biased because it's making an assumption that this weapon is going to kill innocent people, although that could be true, but there is bias. That's a good bias here. Number 12, about sampling techniques, you're going to see those questions, guys. You're going to see probably all of them on the test. Probably less than what you see here, but you will see all of them. So that's why it's very, very important to understand each one of them. At the local community college, 5 statistics classes are randomly selected out of 20, and all the students from each class are surveyed. So let me see if I can. So we have 5 statistics classes. This is the all the classes. You take 5. Only 5 of those. So we're going to select 1, 2, 3, 4, 5, and we survey every single student in the class. This is a cluster, guys. When you pick portion of the population and you go to each portion and survey every single person inside that portion, that's a cluster sample. 13, every fifth person boarding a plane. You count 5, 10, 15, that's systematic. And number 14, a researcher randomly selected 50 of the nation's middle schools and interviewed all of the teachers at each school. Again, this is a cluster, guys. You have thousands of schools, you select 50 schools, and you went to each school, survey every single teacher. That's a cluster. So that is the solution of chapter 1 assignment. Any questions? Okay, identify the class with the greatest and the class with the least relative frequency. Okay, the class with the greatest frequency would be this. And the class with the least will be that. Now, here's how you figure out the class from 2. This is the midpoint, guys. Take one midpoint to the next consecutive one, 110 to 120, that will give you the class width. So the class width is 10. Here's how you figure out what the class is. Take half of 10, which is 5. Take the 110 and subtract the 5, that will give you 105. Take the 110 and add the 5, that will give you 115, but take 1 away from 115, so that will be 114. Because why we take 1 away? Because the next class starts at 115. So we go 1 lower. That's how I showed you how to construct the tables. So for the largest one, it's 105 to 114. Now for the least one, 150, guys, subtract the 5, will be 145. And add a 5 will be 155, but take away 1 will be 154. Okay. B, approximate the greatest and least relative frequency. It's about 0.35 for the greatest. Just read it from here. And for the least, I would say probably 0.04. This is up to 0.05, so about 0.04. I mean, students who put 0.03 will mark it correct as well. Approximate the relative frequency of the 50 class. 1, 2, 3, 4, 5. So what do you guys think it is? About 0. What did you put as an answer? Any student would like to answer this? I would say 0.08 or 0.09. And again, guys, to figure out the class width, just take the difference between 2 midpoints, 110 to 120, that's 10, 120 to 130, that's 10, and so on and so forth. Okay, next question. Construct relative frequency distribution, cumulative frequency distribution, etc. So let's do that. We need the lowest value and the largest value. The lowest value is 32. So you need to do some work here. Largest value is 50. Let's see. If you have your assignment in front of you, you can put it there. 53. Yeah. I see 53 as the largest value. And I said 5 classes, so the class width, guys, will be 53 minus 32 divided by 5. 53 minus 32 divided by 5 is 21 divided by 5. That's a 4.2, and then you have to round it up, so class width is 5. Okay, any questions here? So the class width is 5. So you start with 32, add 5 here, 37. So you add this way, guys. Add 5, it's 42, add 5 is 47, and then 52. And here that should be easy. 1 below 37, 36. That's why I asked you to subtract 1. 1 below 42 is 41. 1 below 47 is 46. 1 below 51, and add 5, it will be 56. And I think students, I'm looking at, I think it's 68862. That's what it turns out to be. Now, relative frequency, guys, you just take the frequency and divide it by the total sum of all frequencies. And here, how many do we have? We have 30. So that will be 6 divided by 30, 8 divided by 30, 8 divided by 30, 6 divided by 30, and 2 divided by 30. Cumulative frequency. Watch, guys, this. How do you do cumulative frequency? Cumulative means how many are there between 32 and 36 here? So it's 6. Now listen to the next one. How many are there between 37 and 41 and the ones before? So you have to add 6 plus 8, 14. Now you have to add 6 plus 8 plus 8, 22. Now you have to add 6 plus 8 plus 8 plus 6, 28. Now the last one, guys, you don't even need to think about it. It has to be the grand total, which is 30. Okay. Identify if there are any outliers. Okay, for outliers, let's see if this is, we need the Q1, we need Q3 for this one. Okay, you could, if you want, if you don't want to do any work by hand, you could put this into your calculator to do that, or we can find the Q1 and Q3 by hand since I put them already in order. Okay, so I have 15 values, guys. The midpoint, it's going to be 15 plus 1, 16 divided by 8, the 8th one. 1, 2, 3, 4, 5, 6, 7, 8. That's the median. That's Q2. Now, Q1 is the middle of the first half. Let's see how many do we have in the first half. 1, 2, 3, 4, 5, 6, 7. So that's easy to find the Q1. If it is an odd number, guys, add 1, that will be 8, divide by 2, 4, count to 4. So that's a Q1. $65. Q3, same thing. Go 1, 2, 3, 4, 82. And that's all I need to find the outlier. And let me show you the process of finding the outliers. First of all, you find IQR, which is Q3 minus Q1. 82 minus 65. And that should give you 17. Next step, multiply by 1.5. That's 25.5. And the third step and the last, before I can tell you if we have outliers, take Q1 65 and subtract 25.5, and then take a Q3, which is 82, and add a 25.5. So 65, that's 39.5. And 82 plus 25.5, which is what, 107.5. And here's any values that are between those two values, not outlier. And any values that are outside this, these are outliers here, and these are outliers there. Okay, let's look at the data set, guys, and decide. Do we have any values that are less than 39.5? Yeah, there is 35. So 35 is an outlier, not 40, 35. And any values beyond 107? No, so it's just 35. Any questions? Okay, so 35 is an outlier. Let's go to the next page. Number 4, the number of runs batted that Sammy Sosa hit in the first 15 years of his Major League Baseball career are listed below. Find the mean, the median. Okay, guys, so we're gonna go to the calculator, show you how to do this on the calculator again. So here's how you do it. You're gonna go to stat, edit. Okay, if you have something in L1, you clear it, guys. Just move the cursor to L1, clear, enter, and enter the data. So let me enter them. $119, $158, $141, $138, $160, $108, $103. Okay, and stat, calc, one variable statistic. Confirm, guys, that your list is in L1. This one should be empty, clear, nothing in it. If there is anything in it, you have to delete it. Otherwise, it will give you wrong answers. So like this, just take a screenshot of this. Make sure that this is how it should show, and calculate, guys. Okay. So can a student tell me what the mean is? What would be the mean?
Nine 96.67.
Yep. 96.67. Okay, let's make sure we understand everything. So all he wants the mean and the median, but let's see. S would be the sample standard deviation, guys. If I ask you, and I know a student asked me, Alessa asked me earlier about the standard deviation. Here it is, right here, 46.48. That's the standard deviation. Now, the second one is also a standard deviation, but if he says you have the population, here he didn't give us the population. He says these are the home runs. So it is a sample. Most of the time, guys, it is a sample. So you'll be using S. You don't use the first value right here and the second value. N is how many values do we have? Minimum value, that's 13. Q1 is the first quartile. And let's see, show you. The median, that's what he wants, 103. And the Q3 is the third quartile, 138. And the maximum is 160. So to answer the question, we just copy them. You see, if you know how to use technology, I'm not requiring you to do this by hand. As long as you know how to use technology, you should be able to do it. And I think the median was 103, and that answered the question. You get it right this way. Okay. Number 5. Again, this is about standard deviation, guys. Here are the batting averages of Sammy Sosa and Barry Bonds for 13 recent years. Which player is more consistent? More consistent means the one who has a smaller standard deviation, because the smaller the standard deviation, the more consistent the values are the mean. More consistent means they are close to the mean. Everybody is close to the mean. So here's how we're going to do this one. We're going to enter the values, first of all, in L1 and L2. So look how I'm going to clear L1, clear, enter, I'm going to go to L2 clear, enter. We're going to enter the values together. Okay, let me pause recording so we don't waste time. So I got the data for the 2 persons in L1 and L2. All you have to do, guys, go to stat calc, one variable statistics, and hit calculate. And I got Sammy Sosa S is 0.0328. Let's say he says 4 decimal places. And let's find S for the other person. You go to stat, calc, one variable statistics, and you need to change L1 to L2, guys. And here's how you do it. Press the second key. Watch. Press the second key, and then number 2, and change to L2. And S is 0.0271. So can you guys tell me which one was more consistent? Do you guys agree with me? It's Barry Bonds because he has a lower standard deviation. If I tell you next week, that never happened before, but let's say I tell you the standard deviation is 0 on your test score, that means all of you scored the same, exact same score. All of you were consistent, 100% consistent with the mean. Okay, 6. Also, I was asked about the z-score earlier. Here's another exercise to do z-scores. For the math part of the SAT, the mean is 514 and the standard deviation is 114. So SAT mean is 514 and standard deviation is 113. For the ACT, the mean is 20.6 and the standard deviation is 5.1. Bob scored 660 on the SAT and 27 on the ACT. We want to see on which test he did relatively better. So you change him to z-scores. Okay, here's the formula, guys. It's value minus mean, which is the divided by standard deviation. Which is the value here for the SAT, they said 660 minus 514 divided by 113, guys. So which is 146 divided by 113, which is, okay, we can use calculator here. 146 divided by 113, 1.29. Okay, let's see ACT. What did he score on the ACT? 27. You put the value first, guys, minus the mean, which is 20.6 over 5.1. So for example, guys, if you want to submit to a university one score, which one would you submit if you have an idea about the average and standard deviation? The z-score can tell you which one to submit. You would submit the one that has a higher z-score. So 27 minus 20.6 is 6.4 over 5.1. They seem to be very close. .25. So I would submit the first one because it is a higher. So SAT, because the z-score was higher. Talking about z-scores, guys. If a z-score is over 2 or less than -2, it's called unusual. So if z-score more than 2 or z-score less than -2, it's called unusual. But if z-score is bigger than 3 or z-score less than -3, it's called very unusual. So most of us guys belong in between -2 and 2. And anything go beyond that, it will start being called unusual or very unusual. Okay, that concludes the assignment.